Are you curious about the outer reaches of our solar system? Today, we're setting our sights on the Kuiper Belt, a vast region teeming with icy objects and dwarf planets. This hidden treasure trove holds vital clues to the formation of our solar system. Join us as we explore the science, history, and captivating secrets of the Kuiper Belt. Let's dive in. First, let's get an overview of what the Kuiper Belt actually is. The Kuiper Belt is a vast, donut-shaped region of icy bodies that extends far beyond the orbit of Neptune. Imagine a giant cosmic donut. It's home to Pluto and Eris, two intriguing worlds visited by NASA's New Horizons spacecraft. But the Kuiper Belt is much more than just these two objects. Scientists believe there are millions of icy worlds here, leftovers from the formation of our solar system. These objects are known as Kuiper Belt objects, or KBOs. Now that we know what the Kuiper Belt is, let's talk about its size and distance. So how big is the Kuiper Belt? It's one of the largest structures in our solar system, along with the Oort cloud and Jupiter's magnetosphere. The Kuiper Belt starts at Neptune's orbit, around 30 astronomical units O from the Sun, and stretches out to about 50 O. But it doesn't end there. There's a region called the scattered disk that extends even farther, nearly up to 1,000 O. Imagine traveling that far, mind-blowing, right? With an understanding of its size, let's talk about the origins and formation of the Kuiper Belt. The Kuiper Belt is like a time capsule from the early days of our solar system. Astronomers think these icy objects are remnants from the solar system's formation. Just like the asteroid belt was shaped by Jupiter, the Kuiper Belt was influenced by Neptune. Neptune's gravity stirred up this region, preventing the small icy bodies from forming a large planet. One fascinating theory, the NICE model, suggests that the shifting orbits of Jupiter, Saturn, Uranus, and Neptune could have ejected most of the original material. This means the Kuiper Belt we see today is just a fraction of what was originally there. Building on its origins, let's examine the structure and characteristics of the Kuiper Belt. The Kuiper Belt is more than just a collection of icy bodies. It's an enormous, donut-shaped region with objects varying in size, shape, and color. These objects aren't evenly distributed, they belong to different groups based on their orbits. Classical KBOs are found in the main part of the belt. They can be further divided into cold and hot classical KBOs. Cold classical KBOs have nearly circular orbits, while hot classical KBOs have more elliptical and tilted orbits due to Neptune's influence. Then we have the resonant KBOs. These objects are in orbits tightly controlled by Neptune, like Pluto. For example, Pluto completes 2 orbits for every 3 Neptune completes, a 3-2 resonance. This keeps Pluto's orbit stable and prevents it from colliding with Neptune. Moving further out, let's explore the scattered disk and detached objects. The scattered disk is a region beyond the main Kuiper Belt with objects on highly elliptical and inclined orbits. These objects were scattered by Neptune's gravity and can venture hundreds of O from the Sun. Eris, the largest known scattered disk object, is a prime example. Detached objects have orbits that don't come close to Neptune, suggesting they were influenced by other forces, like a possible undiscovered giant planet or the gravity of passing stars. Sedna is one such object, with a distant orbit reaching up to 1,200 O. Now, let's discuss the Kuiper Belt's relationship to comets. The Kuiper Belt is a significant source of comets, especially short-period comets. When KBOs collide, fragments can be pushed by Neptune's gravity into orbits that send them sunward. These comets, known as Jupiter family comets, have orbits influenced by Jupiter, leading to short loops around the Sun. Over time, these comets exhaust their volatile ices and become dormant. Some near-Earth asteroids are actually burned-out comets from the Kuiper Belt. Many comets meet their end by crashing into the Sun or planets, or being ejected from the solar system entirely. Continuing with our exploration, let's talk about Kuiper Belt moons and binary systems. Many KBOs have moons, or are binary objects, pairs of objects orbiting a shared center of mass. Pluto, Eris, Haumea, and Quoar are some of the KBOs with moons. Some binaries even touch, forming contact binaries like Arakoth, which looks like a partially flattened snowman. These binary KBOs are incredibly ancient and have changed little since their formation. Their existence hints at a time when collisions between KBOs were more common, allowing them to stick together and form binaries. Shifting our focus to human exploration, let's see how we've explored the Kuiper Belt. NASA's Pioneer 10 was the first spacecraft to enter the Kuiper Belt region in 1983, though it didn't visit any KBOs. The real breakthrough came with NASA's New Horizons mission. In 2015, New Horizons flew by Pluto, giving us our first close-up look at this distant world and its moons. In 2019, it flew by Arakoth, revealing its unique double-lobed shape. Naming and discovery. Lastly, let's look at the naming and discovery of the Kuiper Belt. The Kuiper Belt is named after astronomer Gerard Kuiper, who speculated about objects beyond Pluto in 1951. However, he didn't predict the specific population of objects we see today. The first actual KBO discovery came in 1992, with 1992 QB1 opening the floodgates to countless discoveries. Despite being the first discovered KBO, Pluto was initially thought to be a lone planet. It took 62 years after Pluto's discovery to find another KBO, changing our understanding of the outer solar system. The Kuiper Belt is a treasure trove of icy wonders, offering a glimpse back in time to the birth of our solar system. From dwarf planets to comet factories, this mysterious region is full of surprises. As we develop new technology, who knows what other secrets the Kuiper Belt holds? Thanks for joining us on this cosmic adventure. If you enjoyed learning about the Kuiper Belt, hit that like button and subscribe to Mars 666 for more mind-blowing space content. Don't forget to ring the notification bell so you never miss a launch. Until next time, keep exploring the universe.